The refraction idea is used for different purposes in laboratories, in aquariums, auditoriums, in households and apartments, electronics and equipment, in decorative pieces, in traffic vehicles, to observe, and various others. We will discuss exhaustively about 16 various uses of refraction in our day-to-day life with a detailed analysis, which are telescope, microscope, magnifying glasses, cameras, peepholes on doors, spectacles, to observe, projectors, periscope, binoculars, aquarium, luminance, decorative pieces, to catch the fish swimming underwater, red light indicator, and to see eclipse. Telescope. Telescope has two lenses, one is the eyepiece and the objective. The objective has a large aperture and a large focal length than the eyepiece. Light from the object. The magnifying power of the telescope is the ratio of the angle subtended at the eye and the angle subtended at the lens. Microscope. A convergent lens of a small focal length is used to get magnified and virtual images. The light rays are incident on the surface of the convex lens and are refracted through the lens. The image is formed behind the lens, which is larger than the real image of the object. Magnifying glasses. The magnifying glasses are used to see things that are difficult to read with naked eyes. Magnifiers are made up of a convex lens. The image of the object formed after refraction is an enlarged image. Cameras. High-definition (HD) cameras are in trend these days that allow us to capture minute details of the objects with a good focus of the lenses and brightness, and extraordinary photos and videos. The camera comes with a number of lenses that define its focal length and quality of it to magnify the images and focus well on the minute objects. Peepholes on doors. The lens is planted on the doors of houses to peep outside through the lens to get the view of a person standing on the door. This is because of the refraction of the light through the lens. Spectacles. When the light entering through the crystalline lens of the eyes is not adjusted by the aperture of the eye lens, the image may form either behind the retina or in front of the retina. The lenses of the correct diopter are used to correct this defect. To observe. A crystalline lens is present behind the cornea of our eye. This lens is biconvex and transparent and refracts the light rays entering the cornea and are focused on the retina behind the lens passes through the vitreous humor. Pupils and iris help to adjust the intensity of the light entering and the focal length of the lens. Projectors. The projector comes with an adjustable knob to adjust the focal length of the screen while projecting a slide. Projectors have a lens through which the beam travels and is projected on the screen. The focal length of the lens is adjusted by varying the aperture using a knob. Periscope. A periscope uses both reflection and refraction techniques. The light enters from one lens attached to one end. The light entering from one lens is incident on the mirror kept at the middle, from where the light is reflected 90 degrees, and is passed through another lens fitted on the other end of the periscope. This is used to see the objects and the obstacles, where direct sightseeing is not possible. Binoculars. The binoculars are used to see the farthest objects. This is possible because it comes with a convex lens that produces enlarged and real images of the object. The light is refracted through the lenses of the binoculars and then receives by the eyes. The lens of the eye reads these enlarged images and processes to the brain. Aquarium. Fish tankers and large aquarium plants use glass containers to bred fishes, to study the behavior patterns of the fishes and how they are doing in the environment that they are provided. Luminance. Various laminators work on the principles of diffusion refraction. The rays of light diffuse and travels in all directions or in a straight line depending upon the structure of the laminators. This works on the basis of refraction. The light travels through the glass and is refracted at different angles. Examples are tube lights, bulbs, LEDs, torches, lanterns, etc. Decorative pieces. Many decorative pieces are built using the refraction of light. For example, lanterns, glass pieces refractive white light into different components of light, crystals giving the glossy appearance, marbles, decorative pieces of glass, fluorescent diyas, glossy pebbles, etc. To catch the fish swimming underwater. As the light rays travel inside the layers of the water, and then reflected back, we can see the object under the water surface. Hence, refraction of light from the water bodies gives the view of the object underneath, and we can catch the fish. Red light indicator. Red light has the longest wavelength and hence disperses less in the medium and scatters least. Hence, red light is used on the vehicles during foggy weather and rainy conditions so that the vehicles approaching from a distance can be located. Red light is also used to symbolize the danger and emergency signals. To see eclipse. It is difficult to look up at the sky during the daytime. During the eclipse, it is dangerous to see towards the sun with naked eyes, because of the sudden bright refraction of the rays when the moon starts revolving away, opening the shield after the formation of the ring. The sudden reflection of the rays would harm the eyes. Hence, we use different types of equipment to reduce the intensity of the light passing through our eyes. A floppy disk, black glasses, glasses painted with lamp black, etc., are used to see the eclipse by holding it across the eyes. Frequently asked questions. How does the refraction depend upon the emissivity of the object? The amount of light that penetrates through the object relies on the refractive index of the object, that is the density. The emissivity of the waves from the object depends on the composition, shape, and size of the object. The components of the light which are not captured by the object are refracted from the object, and the same is received by our eyes. Does the frequency of the light is constant even after refraction? The energy of the light beam is conserved in the refraction. The speed of the light varies on entering into the different mediums. Speed is directly proportional to the wavelength. Hence the wavelength varies parallelly to the speed, keeping the frequency constant. Why some objects are translucent? The translucent objects are partly transparent and partly opaque. If a few components of light are absorbed by the object and partly are refracted out, then the object appears translucent. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.